I'm Tim Grance with the National Institute of Standards and Technology, and I'm a senior computer scientist doing research in the Internet of Things.
What is IoT?
IoT, or the Internet of Things, is really the networked connection of everyday objects. It's really an amalgam of physical objects, meaning sensors and actuators, virtual objects, people, services, platforms, and networks. There are many definitions, none of which are particularly authoritative, but that's my kind of working definition of the IoT. I think some key points about it are that it is generally IP-based, resource-constrained, where your memory processing and costs are modest, and it's mostly engaging with wireless protocols, standards, technologies, and processors technologies.
Is it a really big deal?
It's a very big deal. We're looking at a modern world in which the connection of everyday objects, creating a worldwide context in many different industries, things like agriculture, smart cities, jet engines, wearables, ranging from your Fitbit to things embedded in the fabric of your clothes, is really connecting us to a global entity. So it's definitely revolutionizing things like agriculture, smart cities, transportation, various capital industries. If we make just modest progress in some of these capital-intensive industries, like say we grow 5% more food or 5% more efficiencies in our transportation infrastructure, it has tremendous impacts. But it is a world that will be sensor-rich and, frankly, data-obese. I think one of the key points I'd make about this coming change is that we'll tend to overestimate the short term, meaning we'll think it's going to happen a lot faster than we think, but really what will happen is I think we'll underestimate the short term, understate the long-term impact.
And what are the driving forces?
Well, there are many. I think we have these four broad driving forces where cloud, mobile, big data, and social, and perhaps you could add the software-defined anything, XXX, and now IoT. So these things are affecting each other. If we look at mobile, we have maybe 1/3 of the world has smartphones or using 3G and 4G. So we're just at the beginning of change. It's hard, as we've had this tremendous amount of impact of technology, we're just at the very, very beginning. So all these things are new, but coming fast and rapidly. I think it's definitely going to impact us a lot. We have the second era of cloud, we have mobile accelerating, social continues to rise, and big data gets bigger. Business models are evolving, say, in this IoT space. We haven't really sorted all those issues out, but I think it's going to definitely dramatically change and impact our lives.
What about security and privacy?
Well, I think we're going to be deeply challenged by security and privacy. I think we inherit all the current evils and add complexity and epic scale to this makes the problem a lot more difficult. Generally, insecurity thrives, or vulnerability thrives in complexity. It's the fertile ground of vulnerability when you have complexity. Coupled with the fact that we have very diverse ecosystem in IoT, we're going to be dealing with low power devices, resource constrained devices, sensors that will not be maintained, they'll simply die in place. Coupled with how we construct modern systems these days. We construct systems like Lego blocks, we put them together, and our skill sets probably don't scale to this level of complexity. If we go to ultimately, and say in 5 years, to say 50 billion, 60 billion devices, it's going to be a highly interconnected world. We can deploy technology much faster than we can secure it.
You sound pessimistic.
I am, a little bit, but I would say I'm more cautiously optimistic about what we can do. I think we're challenged that our current security thing doesn't really scale. We try to remind people that functionally composing a system does not equal security composition. It's definitely going to be a bumpy ride. However, why am I cautiously optimistic? I think the opportunity and the potential are vast if we extend the IT revolution to these other industries. Again, I talked about the efficiency. If we can make advances in some of these technical areas like graph theory, machine learning, algorithms, and learning how to deal with the math of these epic data sets, along with learning how to better to compose these large-scale diverse systems that can scale, I think it can be a tremendous impact on the future. I think it's going to be bumpy, though.
Any last thoughts?
Well, I like to use this quote from Schumpeter, the famous Austrian economist, that he said that technology is not kind. It does not ask or say, please. I think we have to demand that the technology does ask and it does say, please, and I think that's our challenge going forward.